Welcome back. We're going to start our next chapter reviewing properties of radicals. Remember, a radical expression is an expression that contains a radical. Product property of square roots. Remember, we always want our radicals, just like our fractions, to be in absolute simplified form. And the product property just means that we can break down these radicals into numbers that are multiplied together. For example, I could do 108 is 2 times 54, 9 and 6 make 54, 3 and 3 make 9, and 3 and 2 make 6. These are all prime numbers now. And so we have 3 times 3 times 3 times 2 times 2. There's 3 3s and 2 2s here. When we're simplifying a square root, remember we're looking for pairs. So we're pulling out a 3 and a 2. We're multiplying always when we pull stuff out. And then we have this 3 that's left over. 3 times 2 is 6. And so 6 squared of 3 is simplified form. We use the product property because all of these were multiplied together. Product means multiplication. Let's try letter B. Let's say I'm not sure what I can divide 147 by. Well, 1 plus 4 plus 7 is 12. Can I divide 12 by 3? I can. So that means I can divide 147 by 3. When I do, I get 49. 49 is 7 times 7. We have a pair of 7s with 3 left over. The pair goes on the outside of the radical, and the 3 stays home. That's simplified form. Variables go very much the same way as numbers. 9 we have is 3 times 3. X to the third is 3 x's. We have a pair of 3's, a pair of x's with an x left over. The 3 is on the outside of the radical then. The pair of x's comes out, and then the single x stays home. 3 times x is 3x. So 3x squared of x is our reduced form. Letter D, we have 25. 25 is 5 times 5. And then we have 5 x's. So I have a pair of 5's, 2 pairs of x's with 1 x left over. Remember, all 3 pairs come on the outside of the radical. And then the single x stays on the inside. 5 times x is 5x squared, square root of x. And that will be simplified form. Quotient property. All this means is if I have something that's in a big square root and I can't divide, we can separate that into 2 separate square roots. I want to check each part. So 15 is 5 times 3. Well, I can't pull anything out to reduce that. So we leave the square root of 15 alone. 64 is a perfect square. That's 8. So square root of 15 over 8. That's as simple as it gets. I can't divide 11 and 36. So I'm going to pull out the square root of 11 and the square root of 36. 11 is a prime number, so I know I can't reduce that. The square root of 36 is 6. And so the square root of 11 over 6 is our simplified form. For letter G, we can separate this, the square root of 4, the square root of b cubed, and the square root of 64. I know that the square root of 4 is 2. B cubed is b times b times b. So I have a pair of b's. The pair of b's comes out. And then the single b gets stuck underneath here. And again, the square root of 64 is 8. I can reduce the 2 and the 8 by 2. And so I have 1 times b on the outside is b. We have the square root of b, and we now have 4 on the bottom. And that is simplified form. Letter H, I can't reduce 144 by n squared. So separate that into 2 separate square roots. The square root of 144 is 12. The square root of n squared, remember these are opposite operations. And so we're left with n, and 12 over n is simplified form. Cube roots. The difference between square roots and cube roots is just that for a cube root, I need a group of 3 rather than a group of 2 that we use for square roots. We can also have negative signs underneath our radicals. I'm going to start with trying to reduce 128. I know I can divide that by 4. 12 divided by 4, 8 divided by 4. That gives us 32. I know I can divide 32 by 4. That's 4 times 8. And 8 is 4 times 2. Because it's a third power, I need groups of 3. Yes, we can break those 4s down further, but I don't really want to because I have 3 of them right there. And the 2 is left over. The negative comes out. That triplets of 4 comes out. And we're left with the third root of 2. Remember, we got to keep that third root here to show that we took out a group of 3 4s. And then the 2 is stuck at home. 125, it ends in a 5. I know I can divide by 5. That leaves us with 25. 25 is 5 times 5. And then we have 7 D's. So I have 3 5s, 3 D's, and 3 D's with 1 D left over. So all of my circles come on the outside, 5 times D times D. And then we have this D that's stuck here. 5 times D is 5D squared. And third root of D is left. And that would be simplified form. Letter K. Well, we can divide this up just like we did the other ones to the third root of y and the third root of 216. I don't have any other y's, so third root of y is just going to have to stay there. 216, it ends in a 6. Let's see if I can divide that by 6. And I can. That's going to be 36. 36 is 6 times 6. There's 3 6. So that's going to come out. And that will be simplified form. For letter I can break that into the third root of 8, the third root of x to the fourth, the third root of 27, and the third root of y to the third. If I break each of those down, let's see, 8 is 4 times 2. 4 is 2 times 2. So there's a group of 3 2's. So I'm going to change that third root of 8 to a 2. We have 4 x's. So I have one group of 3 with 1 left over. And the x left over. 27 is 9 times 3. 9 is 3 times 3. So I have a group of 3's. And then y to the third is 3 y's. That's a group of 3. So that comes out with none left over. And I clean all that up. 2 times x is 2x times the third root of x on the top. And 3 times y is 3y on the bottom. And that will be simplified form. All right, letter N. 25 is 5 times 5. And then I have 7 C's and 3 D's. The 5s are going to get stuck. I have 2 groups of C's with 1 left over and 1 group of D's. So on that top part, we have C times D with 5 times 5 times C left underneath. On the bottom, 64, 4 times 16. 16 is 4 times 4, so I have 3 4s. Clean that up. C times D is C squared D. And 5 times C is 25C left underneath that third root over 4. And that's going to be that final answer. Rationalizing the denominator. We rationalize the denominator because we cannot leave a radical in the denominator. It is an irrational number. So I don't know what the square root of 3 pieces are on a pizza. I don't know how to cut a pizza into the square root of 3 pieces, but I know how to cut a pizza into 3 pieces. And so that's what we're saying. We want to be able to know what my denominator is, how many pieces I'm cutting my cookie into or my candy bar or whatever it is that I have. So how do I rationalize the denominator? Well, whatever's in our denominator, if we cannot simplify it, which 3 times n, I can't simplify that at all, we multiply by that value. So times the square root of 3n over the square root of 3n. Remember, we're allowed to multiply like things. These are both square roots on the top, so I can do 5 times 3 times n. And on the bottom, 3 times 3 times n is basically what we have. I cannot pull any pairs out from the top, so 5 times 3 is 15 times n, square root of 15n. On the bottom, I have a pair of 3's and a pair of n's, 3n. I cannot reduce the 15 and the 3 because the 15 is in a radical and the 3 is not. Same thing with the n's, and so that is simplified form, and there's no radical in the denominator. Letter O, cannot simplify the square root of 5. So I'm going to multiply by the square root of 5 over the square root of 5. 1 times the square root of 5 is 1 square root of 5. On the bottom, I have the square root of 5 times 5. That's a pair of 5's. So we pull that out, and I have no radical left in the denominator because we've simplified everything out. We can write the 1 on the outside of the top square root of 5, but we don't have to. Remember, we cannot reduce the square root of 5 over 5 because 1's a square root and 1 is not. Letter P, I cannot reduce the square root of 10. That's 2 times 5. No pairs. I can't reduce the square root of 3. So square root of 3 over square root of 3. 3 times 10 is 30. 3 times 3 is 9. I cannot reduce the square root of 30. Again, that's 3 times 2 times 5. But the square root of 9 is 3. Again, I cannot reduce 30 and 3. 1's a radical, 1 is not. Letter Q. I cannot reduce 2 and x to pull out any pairs, so I will multiply by the square root of 2x over the square root of 2x. Remember, we can't actually multiply the 7 and the 2 because the 7 is not a radical, so it's just going to sit next to that radical 2x. On the bottom, 2 times 2 is 4. X times x is x squared. Cannot do any simplifying on the top, but on the bottom, the square root of 4 is 2, And the square root of x squared is x. I can't reduce the 2x and the 2x because one's under a radical and the other one is not, so that's simplified form. And our last one, 2y to the third. I can't pull anything out of the 2, but y to the third is y times y times y. I can pull a y out and leave a y underneath. So that becomes y. 2y left underneath there, and we have the square root of 3 on the bottom. Multiply by the square root of 3 over the square root of 3. The y on top stays outside. 2 times 3 is 6. We're allowed to multiply them because they're both radicals. And we have the y. 3 times 3 on the bottom is 9. And the square root of 9 is 3. And so this is simplified form. Thanks very much for joining me on this review. Have a great day.